Welcome to ChemVid. Today we're going to learn how to measure correctly in scientific settings and review how to do graphs. Alright, so the first thing we're going to talk about is how to measure. Alright, so as a review, whenever you are reporting numbers, you need measurements, you need a number and a unit, okay? The units are very important because they let us know how big or small something is. So, as a reminder, always put units with your numbers. Alright, the next thing, when you measure with an analog instrument or an instrument where you are looking at the numbers and you have to figure out what it is, not a digital instrument basically, we always estimate one number, okay? And I'll show you what I mean. If you look at these analog instruments, like a ruler, you can see for certain there's 1. This is 1 centimeter, all right? And this would be 1.5 or 1.5 centimeters, okay? So every line there is, you can measure exactly that amount. Now you're going to estimate and see exactly how close it is to the line. So for instance, if you look at C, measurement C, you can see that it's not exactly on the third line and it's past the second line. So I know for sure that it is 2 centimeters, and I know it's 2.1 and 2.2, but it's not quite 2.3. So I'm going to estimate, and I'm going to see that it's a little closer to the third one, the third line. So I'm going to say that this is 2.26. So the whole point of this is so that you can, you estimate or you measure exactly where it goes to, 2.2. And then you're estimating where it is inside the two lines so that you can give a more exact measurement, okay? And that is where sig figs come from. So whenever you're measuring, you always know that you need to measure in between the lines. That's how many numbers you should have, okay? So for B lies straight on 1.5. Like, that's pretty easy. It may be a little off to the right, but it's pretty much on the line. So I would label that one as 1.50. And you may think, well, why do you have to add the 0? It doesn't actually mean anything, right? But wrong. It's actually another sig fig. You're telling the scientist that the length of your whatever you're measuring is exactly 1.5. It lies exactly on the line, okay? So zeros make a big difference when you're measuring, and they need to be included, all right? Over here for A, we have 0, but again, you can measure in between this line, so it would be 0.0. Silly, yes, but that's how we measure. That's how we are precise, okay? And for D, I would say that's about, 3.2, maybe 1, maybe a little bit off to the side there, so 3.21. But yes, that's how you do it, okay? All right. So the next thing that we're going to talk about is a scale, or it's called a bench scale, okay? And as you can see, it's analog. You have to judge between the lines just like you would have to a ruler. So how much does a chicken weigh? So they have some chicken on there, and I want to know how much it weighs. So if you look, the black numbers are in pounds, and the red numbers are in kilograms. Okay, it's a little easier to see right here. So whenever you're measuring something, you always have to take into account units and how big it is, all right? Now I look at this guy, and it looks like the line is directly on 1, maybe a little bit off to the side. So I need to find out what each one of these little lines means. So what I do is I'm going to count up the spaces between two marked values. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 spaces in between 0.5 and 0. So on my calculator, I'm going to just take 0.5 and divide it by 8, okay? And that's going to give me what each one of these lines mean. And when I do that, I get 0.05. So that means that if I'm looking over at this 1, I would probably estimate that it is 1.05, 1.049, something like that, because it's a little bit over, but it's not quite to the next line yet, okay? And if you're doing the pounds gets even trickier, because when you count out these lines, you get about 0.375 for each line. So while I'm measuring this, I mean, like, it's important to be able to measure, but wouldn't it be easier just to have a scale that has just a big 1 and a half and a 2? Like, why would anyone want to have something this small? So thinking about that, why would a butcher want a more sophisticated scale? And well, my first thought is that a butcher wants to be able to sell his or her meat, to the most accurate measurement. When I sell a pound of meat, I want that pound of meat, the value of that coming back to me, right? And so for certain things, we want really precise scales or really precise measurements so we know what's right and we know what is correct and we can make our money. For a scientist, you want to have really precise measurements so that you can make sure that your calculations are accurate and what you're doing is accurate in your lab. All right, next. Another analog instrument that you're going to use is called a graduated cylinder, all right? And it looks like this. And one key thing to remember is that water always bends. Some people like to refer to it as sticky because it sticks to the sides of the wall, okay? And so for that, you always measure at the bottom of the meniscus, right here, okay? The bottom of the meniscus is where the water would lie if it wasn't attached to the sides, okay? So I'm going to look at the bottom of this meniscus, and it's here. So this big line is 30, 31, 32, 33, 34, 35, 36, and it's not quite to 37, so I'm not going to say that, but I am going to estimate one digit, and I'm going to say it's 36.7, because to me it looks like it's up closer to the 37 mark than the 36. So I'm going to say 36.7. And that is how you measure with a graduated cylinder. Digital instruments are so much nicer because you do not need to estimate a number. In fact, the digital scale will do it for you. So like we use scales to measure our mass. Inside, that already calculates the exact mass, and then the last digit on the scale that it gives you is the estimated value. And that's why sometimes it goes up and down and it kind of fluctuates. It's because the computer inside is trying to figure out if it's a little higher or a little lower, okay? So you don't need to estimate. The computer does it for you. Love digital instruments. All right, so looking at this scale, really easy to say. This little weight right here weighs 1.102 grams. Very nice, very precise, very easy. All right, let's do a little bit with graphing. You guys have known how to graph and how to do things with graphing. So I'm not going to go over a ton of things with you, but I would like to remind you of a few things. All right, so there are two main types of graphs. Pie graphs are used to graph percentages, but we don't really use those a lot, so we're not going to go into them. But bar graphs and line graphs, the two on your notes, those ones we do use, all right? Bar graphs are used whenever you're trying to compare data. So, for instance, in a lab where I have an unknown substance and I'm trying to compare it to other densities to see what the identity is, that would be the perfect time for a bar graph because I'm comparing densities, all right? In this one, we are comparing candies to how many positive reviews they have. And I just want to get a visual and see kind of what's going on. Most people are visual learners, and so therefore graphs are very helpful when you're trying to see information and understand things. So we'll use graphs a lot because it's the best way to communicate our results. All right. So over here I have my graph, and there are a few things that you need to consider when creating the scales for your graph. You always need to make sure that you are using the maximum volume of your graph, okay? So for instance, this one, if I look, my values are from 61 to 79, or to 85, sorry. So if I started at 0 here and went up by tens, 0, 10, 20, 40, 50, 60, 70, 80, 90, then I would have, I would take up most of my graph, but it's not going to show me as in detail the difference between 61 and 64. So what I might want to do is, instead of starting at 0, I might want to start at, let's say, 50, and then go up from there. And that way, when I look at the graph, I can see the difference between 61 and 64 with more clarity, okay? So whenever you are doing a graph and setting the scales, you always want to have a nice appropriation of space, okay? It should fill up the graph, and I should be able to see what I need to see, all right? So the second thing you need to consider is, what are you trying to get your data to tell you, and how best can you get that data on the graph? Like, what is the best way to show your data so it helps your reader understand what they are supposed to know, okay? So those two things are really important, and that's what you need to think of when you're doing your labels. Another thing, your axes should always be labeled. You should always have a title, and if you have units, you should always have units on your axes. Okay, so this one is just positive reviews, and they're just numbers. But if it was something like the number of deer, okay, you would want to make sure that you have units on there. All right. What should you always include in your analysis for any type of graph? Always include numbers, all right? The reason why you have a graph, the reason why you do a lab, is so that you can have numbers to compare things to, all right? So for here, when it says which candy was the most popular and why, you don't just say chocolate, or sorry, not chocolate, M&Ms, because they have the highest value. You want to say M&Ms had a higher value, 85. Kit Kats had a 79. So there's a 6 point difference, but M&Ms ended up being the highest, okay? You want to take your numbers and really help people understand what's going on. All right, so those are those questions. And you can go ahead and graph and then answer the rest of the questions and practice your bar graphs. For line graphs, you can see that line graphs are the most common, all right? They're the ones we use most often because they relate to values, okay? So, for instance, we talked about density, and density is mass versus volume. So, when I plot this, or when you plot this, I'm going to have mass and volume, and then I'm going to have dots with a line. And the slope of that line is going to be my density. A graph can tell you things and do averages for you that are much more precise than just doing our regular average, okay? So line graphs are used whenever you're trying to relate information. A trend line is also called the line of best fit, and it's the line that goes through almost all of the points. It needs to go through the points nicely, okay? And the rest of these questions are going to ask you to calculate the volume using density equals mass over volume. It's also going to ask you to calculate your density with your slope and compare them, all right? And then the final one, you have a sample, an unknown sample, and I want you to justify if this is gold or not using your graph. So make sure when you answer this question, don't just say, yes, it's gold, or no, it's not gold. Say, if you look at the graph, you can see that. Like use the graph to justify yourself. All right? Go ahead and finish up the rest of the packet. Make sure you graph, use labels, all that good stuff. See you next time.